Hello everyone, this is Dr. A.P. Nurekar from Vidyapratishthan's Kamalnayan Bajaj Institute of Engineering and Technology, Baramati. I welcome to all of you in this particular lecture series of Calculus for GATE Examinations. And this is lecture number 2 in this particular series. So in first lecture already we discussed about a pattern of examination along with content which are from engineering mathematics, and we are discussing calculus which is for all branches of engineering. So therefore these are the branches: civil, mechanical, ENTC, electrical, computer, IT, and other branches also. So in the last period we already discussed about the first part, that is limit. Outline of this lecture series that involves limits, continuity, differentiability, maximum minimum of function, integration, and properties. And in first lecture we already discussed about the problems of limits along with the basic concepts which are involved in that. So in this particular lecture we are going to discuss continuity of a function as well as differentiability of a function. Continuity and differentiability we are going to discuss. So function fx, these are the standard results, is said to be continuous if left hand limit is equal to right hand limit is equal to value of function at a. So this is a definition of continuity of function at a particular point x is equal to a. Then function fx is said to be differentiable at x is equal to a if limit of fx plus h minus fx divided by h as s tend to 0 exists, and we denote that value as f dash of x. So these two definitions are required while dealing with the problems which we are considering in this particular lecture. And we know this is very standard result. Slope of a function y is equal to fx is given by dy by dx. This result also we are going to apply. So there are three standard results you need to remember. That is, first is a continuity, means left hand limit of function is equal to right hand limit of function at that point, and that is equal to value of function at that time. Means function is said to be continuous at x is equal to a. This is the right hand limit of fx as x tend to a plus. This is equal to limit of fx as x tend to a minus. This is equal to value of function at that point. And this is about differentiability. And one more standard result, that is slope of y is equal to fx is given by dy by dx. At that point you can find. Then we go to the problems based on differentiability and continuity. So problem number 1, consider the function y is equal to mod x in the interval -1 to +1. All these problems I am taking from the GATE examinations only. In this interval the function is, consider the function y is equal to mod x in the interval -1 to +1. In this interval the function is continuous and differentiable, continuous but not differentiable. Third option C, differentiable but not continuous. D is neither continuous nor differentiable. So we have to choose one option among these four. First we look at the graph of function y is equal to mod x. While drawing any graph, this is a very standard example. We draw x-axis, we draw y-axis, we have origin, then line, means graph y is equal to mod x is this particular part. When x is greater than 0, it is this line. When x is less than 0, it is this line. So this entire part is graph of function y is equal to mod x. Now, if you look at this function, we say that where function is not differentiable. Function is not differentiable if it has a corner point. If you look at this function, it is continuous everywhere. There is no break in the graph of function. So it is continuous, but there is a corner to this graph at x is equal to 0. So x is equal to 0 is a corner point, means function is not differentiable at x is equal to 0. So option is here. It is continuous but not differentiable in this interval. At least one point we have. So function is continuous but not differentiable. That is option B. And this is most famous example which appeared in the GATE examination. Another example which is exactly similar. Consider two statements about the function fx is equal to mod x. P. Statement P. Fx is continuous for all real values of x. And Q is fx is differentiable for all real values of x. Then which of the following is true? P is true, Q is false. Means what? Function is continuous but it is not differentiable. P is false, Q is true. Both P and Q are true. Both P and Q are false. Again, if you look at graph of function, it is exactly similar as like last example. This function fx is equal to mod x is continuous but not differentiable at x is equal to 0. So obviously our option is A. P is true means function is continuous. Q is false means it is not differentiable in this particular case. So we have what answer as A. It is very clear, exactly similar as like last example, but it is in the different form. This problem is in the different form. So I think you are getting this. So we go to next problem number 3. Which of the following function is continuous at x is equal to 3? A. F of x is 2 if x is 3. Which is equal to x minus 1 if x is greater than 3. Which is equal to x plus 3 divided by 3 if x is less than 3. B part function is defined as fx is equal to 4 when x is 3. This is 8 minus x if x is not 3. C is f of x is x plus 3 when x is less than or equal to 3. Which is equal to x minus 4 when x is greater than 3. And D is fx is 1 by x cube minus 27 when x is not 3. Now if you look at function is said to be continuous at x is equal to 3 if left hand limit is equal to right hand limit is equal to value of function at 3. So we test for A part because here we have got this gives value of function, this gives right hand limit, this gives left hand limit. So we go for case 1. In other cases it is not there. So f of 3 is 2 obviously. When you substitute x as 3 it is already given f of 3 is 2. Then limit of x plus 3 divided by 3 which is left hand limit as x tend to 3. Means put x as 3 here. So you get 3 plus 3 6 divided by 3 means 2. Similarly right hand limit f of x means limit of x minus 1 here x greater than as x tend to 3 is substitute x as 3. 3 minus 1 that gives 2. So limit of f of x as x tend to plus 3 which is equal to limit of f of x as x tend to minus 3 which is equal to f of 3. So function is continuous at x is equal to 3. Means here we have option is answer is A of this problem. It is very clear, just by checking you can easily get the answer. So we go to next problem. The value of x for which the function x square minus 3x plus 4 divided by x square plus 3x minus 4 is not continuous R. the values of x, values, it is actually values. So 4 minus 1, value of x are 4 and minus 1, 4 and 1, minus 4 and 1, 4 and minus 4 and minus 1. So if you look at this function, which is x square minus 3x minus 4 divided by x square plus 3x minus 4. So we factorize denominator. And what are factors? Obviously factors are x plus 4 and x minus 1. Rest of the thing is numerator as it is. Now denominator becomes 0. If the denominator is 0, then function is not defined. Means there is no question of continuity. So function is not continuous when it is not defined, obviously. So denominator will be 0 when x is minus 4. And obviously x is 1. So fx is not defined when x is minus 4 and x is 1. Means function fx is not continuous when x is minus 4 and x is 1. And that is option, I think, C. Yes. So our answer is C. So this is a very simple example. You need to just only factorize denominator and you have to see that where it is not defined. So we go to next problem. If at every point of a certain curve, the slope of tangent is equal to minus 2x by y, the curve is straight line, parabola, circle and an ellipse. So slope means what? We know slope is given by dy by dx. And dy by dx is given and that is minus 2x by y. So solve this differential equation. So y dy is equal to minus 2x dx. Integrate this. Integration of left hand side is y square by 2. Integration of right hand side is minus x square plus constant of integration. So we have y square divided by 2 plus x square plus is equal to c. Or if you divide it by c, you can write y square divided by 2c plus x square by c is equal to 1. And obviously we know standard equation of ellipse is x square by a square plus y square by b square is equal to 1. And obviously whatever situation given, we have got answer as an ellipse. So this curve is an ellipse. So that is our fourth option, I think D. So answer of this problem is D. I think you are getting. This is also very simple example that was appear in the GATE examination. So next problem. The formula used to compute an approximation for a second derivative of function f at point x0 is, these are the options, f of x0 plus h plus f of x0 minus h divided by f of x0 plus h minus f of x0 minus h divided by 2h, f of x0 plus h plus 2 times f of x0 plus f of x0 plus minus h divided by h square. And last option is f of x0 plus h minus 2 times f of x0 plus f of x0 minus h divided by h square. So we have to check which option is correct. So we know derivative of function is f dash of x0, which is limit of f of x0 plus h minus f of x0 divided by h as h tend to 0. So second derivative is, if you apply this formula again, either you can write f of x0 plus h minus f of x0 or f of x0 minus f of x0 minus h, this way. So f double dash x I am writing as f dash of x0 minus f dash of x0 minus h divided by h as h tend to 0. So f double dash of x0, that is f of x0 plus h minus f of x0, put value here. F dash of x0 you apply here. That is what? It is f of x0 plus h minus f of x0 divided by h. Minus, apply this formula, where x0 is replaced by x0 minus h. So it is minus f of x0 plus h minus h, that gives f of x0, minus f of x0 here, we have to replace x0 by x0 minus h. That's why it is minus of f of x0 minus h. And this h as it is. So, simplify this. If you simplify, we get 1 by h means 1 by h square common denominator. So, f of x0 plus h minus f of x0 minus f of x0 means that gives minus 2 f of x0. Minus of minus is plus. F of x0 minus h divided by h. And obviously, that is our option number D. So, answer of this problem is D. Problem number 7. The function fx is equal to sin x times sin x satisfies the following equation. F double dash of x plus fx plus t times cos x is 0. The value of t is, it is not given. So, we have to find value of t. So, fx is x times sin x. Find its derivative and put those values here. F double dash of x you need to find. And you have to substitute all these values here. So, find derivative of fx. It is apply product rule x times cos x plus sin x. And f double dash of x will be derivative of this quantity. That is x times sin x with minus sign plus x times cos x derivative. X derivative is 1. That's why it is cos x. And derivative of sin x is cos x. So, we have f double dash of x plus fx plus t times cos x is x cos x, yes, minus x sin x plus cos x plus fx means x times cos x plus sin x, and this is plus t times, yes, x sin x because it is fx, x times sin x plus t times cos x. We get this. So, this term with plus minus sign get cancelled. Cos x plus cos x is 2 cos x. So, cos x is common. So, we have 2 plus t cos x. This term plus this term. So, we get 2 plus t as 0 means t is equal to minus 2. So, answer of this problem is t is minus 2. It is very simple. Then last example of this particular lecture is let fx be a polynomial function g of x, and g of x is what? F dash of x, its derivative. If the degree of fx plus f of minus x is 10, then degree of gx minus g of minus x is. So, we have given degree of fx plus f of minus x is 10. So, for a while we assume it will be better for our further calculations. Fx as 8, 10 into x power. It is polynomial function of degree 10. That's why we are considering like this. Plus a9 into x power 9 and so on up to a1x of a0. So, f of minus x, how you obtain? Where there is x, just write minus x. So, we get a10 into x power 10 minus, because we are replacing x by minus x. So, it is minus a9 of into x power 9 plus minus alternate. So, it is minus a1x plus a0x. Then f dash of x is g of x, which is derivative of this quantity. So, it is 10 of x power into x power 9. Then derivative of this quantity is 9a9 into x power 8. And this way we get a1. This term will be 0 because we are taking a0, a1 up to an, all are constant. Then f dash of x is this g of x. Then g of minus x in this relation, replace x by minus x. So, we get minus 10 a10 of x power 9, and this is 9a9 x power 8. Next term will be minus plus alternates, and last term will be a1. So, g of x minus g of minus x will be So we have to just subtract this term from this. So minus of minus will be plus. So that's why it is 20a10 into x power 9. This term will get cancelled because this is with plus sign. We are subtracting this. That way, next term will be 16, 8 plus 8. That gives 16a8 x power 7. And obviously, we have to just check the degree of that function. So, degree of gx minus g of minus x will be 9. So, that is our final answer. So, do more practice, and as we know, practice makes man perfect. That's why I'm giving some of the problems as an assignment problems. And all of you subscribe channel, this particular channel of engineering mathematics, so that you can get latest updates and videos on it. So I'm giving few examples. You can note down. The function y is equal to mod of 2 minus 3x in the interval. In this interval, the function is continuous. Yes, just note down this. For all x belongs to R and differentiable for all x belongs to R. Continuous and differentiable. So note down this problem. As well as second problem also you note down. Go through all these options and verify that answer is C. What should be the value of lambda such that the function defined below is continuous at x is equal to lambda? Function is defined in this manner. You verify that these are the options given and your answer is. Okay, so note down this. The next problem, an assignment problem is, if the function is continuous at a point, the limit of function may not exist at the point. The function must be derivable at the point. Limit of function at the point tend to infinity. The limit must exist at the point and the value of limit should be the same as the value of function at that point. And you will find answer is D. So you all verify and try to solve these three assignment problems and do more practice. Go through, get question papers, previous question papers, and you find out the questions from that. And whatever problems today we discussed, those problems are actually from the GATE examination question papers only. So I hope all of you like this particular video. I wish you all the best, happy learning, and I'm thankful to all of you for watching this particular video. So thank you very much.